Hello, so today we are going to take a look at this problem called length of longest Fibonacci sequence. And the problem says that we get a list of positive numbers, and we want to return the length of the longest subsequence of that array that has length 3, and that satisfies the property that AI equal to AI minus 1 plus AI minus 2. So similar to Fibonacci sequence, the first two numbers, the sum of two numbers is equal to the next number. And so subsequence here means that we are looking for a non-contiguous subsequence of the array, such that the sum is going to be equal to of every two element is going to be equal to the next one. So here, if we take a look at this example here, 1, 2, 3, 4, 5, we can, so the 1 plus 2 is 3. So this subsequence is definitely in. And then 4 is not equal to 3 plus 2, is not equal to 1 plus 2, so we don't take 4. But 5 is equal to 3 plus 2. And so the subsequence 1, 2, 3, 5 is what we are looking for, is the longest one we can have. And so we return 4, the length. And so you can see here we skip it 4. So it's what we are asking here is subsequence. And for the property to hold, we need at least 3 elements, right? And so if we don't find such a subsequence, we should just return 0. Yeah. So this is the problem. Now let's see how we can solve it. Okay, so let's see how we can solve this problem. So let's take the first example here. So example 1. So for this first example, let's say we have this array, 1, 2, 3, 4, 5, 6, 7, 8, right? So if we take a look at this one here, what are the different, can we find like any Fibonacci subsequence? So for example, this one with 3 is equal to 1 plus 2. And then 4, no, we can take that one, but we can take 5 because 5 is 3 plus 2. Is 6, does 6 work? It doesn't really, it's not 3 plus 2, it's not 5 plus 3, so we can't take that. Can we take 7? 7 is definitely 4 and 3, but we didn't take 4, so 7 doesn't fit into this sequence. 8 does fit because 8 is 5 plus 3. And so one subsequence we have here is 1, 2, 3, 5, 8. So the length here is equal to 5, right? Can we do better? So if we take a look again, well, definitely 7 and 4 and 3 gives us a sequence, right? 3 plus 4 is 7. 3 is also 1, 2. So we have another sequence 1, 2, 3, 4, 7, which has also length 5, right? Can we take 6 and 3? No, because 3 there is no third element that will give us. If we had 9, then maybe, but here no. So the only two subsequence that, well, we have definitely the subsequent that is smaller, which is just 1, 2, 3. So we have this sequence, but this one is already smaller, right? Equal to 3. We have, yeah, all the subsequence. This one also is a subsequence, but our result should be just 5, right? So how can we apply this? So one idea we can think of here is that what's the property of the solution? So so the property here is that basically we have x and y, right? What are the next two elements? So the next two elements would be y and x plus y, right? For example, if I take here 1, 2, 3, 4, 3, 5, 3, 5, 8, right? Let's say, for example, this is x, this is y, right? Then the next iteration, while we have x and y here, and 3 is x plus y, right? So 3 here is x plus y. This is y, right? And then we advance again. We have, this is the previous y, right? And then this is x plus y, right? So the property, this is the normal property of Fibonacci sequence, right? Because here the property is that what we are looking for is that ai is equal ai minus 1 in the subsequence, of course, not in the array. And so this is just f of I equal to f of I minus 1 plus f of I minus 2. So this is the definition of Fibonacci sequence. So what we can do here is take basically every two pairs of the array, right? And see how what's the max length we can get. What's the max length Fib sequence we can get with these two values. What this would mean basically is that, well, we will go for I from, let me just maybe write it in the, so in a more pseudocode way. So what we will do is we will take I from 0 to n, and then we'll take j from I plus 1 to n, right? So you can think of it as I is here, g is after that. And we are looking for any other element here, for all the elements after that, that give us, that have the same diff. Right? And so if we, once we have these, well, we could just do my formula here, what I said here, that we have xy, and then the element that was at y becomes the new x, and the element y is x plus y, right? So the way we can do that is we can say, okay, let's say x starts out as the aj, right? Because now we know that ai aj is one of the pairs we are looking, the pairs that we are taking for this subsequence. And so here, this is ai plus aj. And the length is 2, because we already supposed that the subsequence includes these two elements. And from there, we could just do a while loop. And while y exists in the array, we will try to see if the element that verifies the Fibonacci sequence exists in the array, right? And so to do that, well, we will just do this formula for the next element. So what that would mean here is that we will say, okay, x is going to become y, and y is going to become x plus y, and the length just increased by 1, because if this exists, then if this exists in the array, then we have one more element that verifies the Fibonacci property, right? And so pretty much once we have this, we have the maximum length we can get by choosing two pairs, the maximum length of a Fibonacci sequence that starts with two pairs. And once we do it for every pair in the array, so this is just a brute force, we definitely have the solution by then. And so what this would mean is that initially we'll choose res to be equal to 0, and then here we would do res equal to max of res and the length that we found for this pair. So pretty much this is a brute force solution. And what we are doing is we are taking every two pairs of the array, finding the maximum subsequence that we can find in the array that starts with these two pairs, right? And then finding the length of that and picking the max of all of these lengths. And the way we are going to find the pairs, like the other elements that are in the same subsequence as these two pairs, is that we are just going to construct it and then check if it exists in the array, right? And so how can we check if it exists in the array in an easy way that doesn't add to the time complexity here? Well, we could just create a set, right? Create a set of the elements in the array that will make it easy to check. And at that point, we can just check y is in S, right? So the main idea here, again, brute force, take every two pairs of the array and then construct what, if there is a subsequence what would be the next element? The next element would be the sum of these two pairs. Check if that is in the array, and then do the same thing again, until you find the end of the subsequence. You find sum of the previous two elements that is not in the array. So that means we found the end of the Fibonacci sequence, and so we stop and try a new pair, right? And so let's try to write this a little bit in a little bit of a cleaner way. So this is the brute force solution. And let's call it length of longest Fibonacci subsequence. And we are going to get an array as input. It's called A. Now we will just need first the length of the array. We will need the set that will help us check with an O of 1 operation if a value is in the array. So that would be set of A. And now we can just do our two loops to check for every pair in the array. So let's do that in a different color. So for I in the range of n, and as I said, since I want this ordering, so I is going to start like this, and then G is going to be after I, and so that would mean for J in range of I plus 1 to n. Now I can start constructing my subsequence that starts with these two pairs and check the maximum length that we can reach with that. And so what are we know the first two elements are AI and AG, right, by definition. The next element then is the sum of these two, right? And so that would mean here that the first x that we are going to check with is x is equal to AJ, right? These are the next two elements. And then y is AI plus AJ, right? And then the length, well, we are starting with these two pairs, so the length here is equal to 2. And so let's call this here L. So L is equal to 2. And now we are going to do our while loop. So while here, what we are going to do is while this value here, so that we can check first, like let's say for example, if we had 1, 2, 3, 4, like we had earlier in the example, if we are at 4 here, if y is equal to this 4, sorry, if what I meant actually is that if, let's say, if we have our I is here and G is here, then AI plus AJ is equal to 5. And we will find that here, right? But if it's 3 and 4, let's say the array is just this, then 3 plus 4 is 7. 7 is not in the array, so we'll exit and we won't count that, right? So what we'll check here is while I is in S, keep trying the next Fibonacci element, Fibonacci sequence, like the next value in the Fibonacci sequence, and check if that is in the array. And so that would mean here while y is in S, we will construct the next value. So that would mean here that x and y, x is going to take the value of y, right? So because for example here, if we are going to the next element, then x will become here and y will become the next element, right? Which is going to be the sum of these two. And so that would be x plus y. And the length increases by 1 every time we have a new element, right? And from there, now we are going to need to check if this is the max length we have so far. And so we could just say max of res and L. And then at the end, once we processed all the elements, we need to return res. So somewhere here, return res. Okay. So let's clean this up. And yep, so this is pretty much the brute force solution for this. Now, what is the time complexity here? So we definitely have an O of n here and have an O of n here. So we have at least O of n squared. What about this here? So for an element, to be able to get the maximum subsequence you can get to get to it with x plus y is log of that element, if we call that element is m. And so since the array is increasing, we could just pick m to be the max, and that will give us the max possible number of operations we will do in the for loop, while loop, right? So what this would mean here is that this here for loop would be at most this while loop O of log of m, such that m is the max of the array. Okay, so now getting all of these together, we have an n for loop, and then n for loop, an iteration for loop, and then underneath that we have log of m. So overall, our time complexity here is O of n squared log m, right? N squared for this, and then log m for this time. Now, in terms of space, the main thing we are using is this set here, which contains all the elements in the array. And so, in terms of space, we are using also just the elements in the array. So, we have O of n space. Cool. So now let's write this solution down, make sure it passes on some test cases, and then next we will see after that a dynamic programming solution. Okay, so I have here the solution that we just saw in the overview. So yeah, the two for loops, and then try to find the next logical Fibonacci sequence element and see if it's in the array, and keep doing that for this pair until you find the maximum length we can reach. Check if that's the max, and then at the end here there is one new thing here that I added, which is if the length is less than or equal to 2, that means we didn't find any Fibonacci sequence, because the smallest Fibonacci sequence has to have at least 3 elements, right? So in that case we return 0, but if we have more than or equal to 3, then we return the result that we found. I have a couple of test cases here. We can just run them, make sure all the test cases pass. They all pass with these asserts here. Yeah, so that's the brute force solution. Next, let's take a look at how we can solve this problem using dynamic programming. Okay, so now let's see how we can come up with a dynamic programming solution. So the main thing we need to come up with is what is our state, right? And usually there is a hint of the state from the goal. So the goal here is to find the length of the longest Fibonacci subsequence ending at any position in the array. Like it doesn't have to end at the end of the array. And so one other thing that so we definitely know that we need this portion here, right? So this needs to be the value, a length of the longest fib subsequence, right? So this is definitely part of the state value, basically. Now, to determine if we have I and j, and we want to know if k is part of the sequence or not, what is the question we should ask, right? Or actually, let me ask this in a different way. So if we have, like in the reverse order, we could do it in k after j, but we could also do it like this. So j, I, and then k here. How can we know if k is part of the subsequence? Is in the fib subsequence ending with I and j, so the pair here. So that can happen only if the difference between the two, the difference between these two is equal to the same here. right? And also it can be if AK plus AI is equal to AJ, right? So AJ is equal to these two. That means that K is the element before I, right? That means K is part of the subsequence, right? And so from this, we can kind of divide our problem into subproblems, because we have a way to divide the problem here. Now, that means that our state can be the length of the longest Fib subsequence ending with I and J, right? Because that will allow us to know this. So if we have a K that has this relationship, that means, well, our subsequence just increased by 1, right? And so let's define this formally as dp of ij, which just would mean here the length of the longest Fib subsequence here, let's just clarify that, ending with I and j, right? And so with that, we can write our recurrence formula here. And so let's try it. So recurrence. So what this would mean here is that the dp of ij, we increase by 1 if we find a k that has this. So it's either it didn't change because we didn't find k here, or what we had before, like with another element, was better. So either what we had before or this k here gives us a better subsequence. Now we have the rest of the array here, right? So what is we have this entire portion. So this entire portion here, let me just clarify it maybe below. So we have k, we have I, and then we have, let's try this differently. So we have k here, and then we have I, and then we have j, right? And so here, this here is the length, this here is the subsequence ending with k and I. And so the value that we can find here is dp of k and I, right? If we find that ak plus ai is equal to aj, that means we can add +1 here, right? And so that means here, this is just 1 plus dp of k I, right? Because we have a new element that we can add to the subsequence, which is j, right? So now that we have our recurrence relation, we need to determine what is the base case that we are dealing with. So the base case here, this is for each subsequence ending at ij, the length of the Fibonacci sequence by default is 2, right? Because, well, with 1 and 2, you can't tell it's not a Fibonacci sequence because we don't know yet, so we can just assume it's of length 2, and then at the end, if the length is just 2, we can just return 0, right? And so our base case here can be that for every I and j, right, we are going to just say that dp of ij is equal to 2. So we will initialize all elements to 2 by default. And then after that, we will need to determine the, usually we can determine the base case before the recurrence, but it doesn't matter here very much. What is the order of iteration that we want to do for our for loops here, right? So if we look at this, what this would mean here is that to know the value for an element, we need to have calculated the elements before it. So for I, we need to have calculated for I minus 1 and I minus 2, right? And so the order needs to be increasing, right? And so we could just, so what we can do here is start with j, right? Start with j for j in the range of n. And then I is smaller than j, so just try the elements left of j. And so that would mean for I in range of j, so it ends at j. And then what is the k values that we are going to try here? So at j, we are going to try all the i's before it. And for I, we are going to try all the k's before it. And so k here is going to be in range of I, of course, right? And then we could just plug our formula by checking if this is true, then we use this recurrence, otherwise we just leave the value as it is, right? So now that we have kind of what we need for our DP solution, we can just start writing it here. Okay, so first, the function here is length of longest Fib subsequence, and then we have the array, right? So the first thing is we need the array length, right? Then we need to initialize our DP. As we said, the base cases here are all the values will be initialized to 2 initially, so that would mean 2 for, it's a 2D array because we need I and j, right? So range of n, and this is going to be for, this is in range of n, right? Now the next step is to start our iteration here for I, j, and k, right? So let's see, for j in range of n, and then I is before j, so that would mean we would need I in range of j, and then k is in range, is before I, so in range of I. And now we can do our recurrence, but first we have to check the condition to confirm it. K, I, and j are part of the same Fibonacci sequence. And so to do that, here we can check if a of k plus a of I is equal to a of j. So if this is the case, then we do our recurrence. Our recurrence was dp of ij is equal to the max of dp of ij, and then 1 plus dp, because we have this, this condition is true, so dp of ki. And now at the end we need to return the goal, which is the length of the longest Fib sequence ending at any positions in the array, right? So we basically need to take the DP array and pick the max of all values, right? So to do that, here at the end, we could just say return. So first, let's take the max, right? So let's take the max of each array in the DP, right? So maybe here, let's say values. So the max of each 4 values in DP. And now we can, because we initialized all of them to 2, if the longest one is just 2, that means we don't have a Fibonacci sequence, because 2 elements don't constitute the Fibonacci sequence. So we can here just return res if it's bigger than 2. Otherwise, we can just return 0. And that's pretty much it for this dynamic programming solution. Now, if we analyze this one here, we can see here that we have O of n here. We have O of n here as well. And then we have another O of n at most here. So overall, this solution here will give us O of n cubed, right? So it's not very optimal. So let's first try to optimize it before running it on some examples. So the main candidate here is this one, is the inner for loop, because we have to check, we kind of have to iterate, right, through 2 pairs at least, so that we can know if we have a Fibonacci sequence or not, right? So the main candidate here for optimization is the inner for loop here. So let's see how we can optimize it. So we know that if ak plus ai is equal to aj, that means that here, well, aj minus ai is equal to ak, right? So what this tells us is that if we have a map of the values of the array, so if we have a map of the value to I, and the value here is a of I, then we could just check for the index of the difference, right? Index of the difference is in this map here. Let's call this one index of map, or map indices map, something like that. So if it's there, that means there exists a k that has this condition here, right? And so we don't need to do the condition, we don't need to do the for loop, right? We can shortcut these two in one operation by just having a map, pre-processing step where we create a map of the value to the index. And now we just check if we have a value ak that has this condition. And of course, k has to be before I, so we need to check that the index map of this difference that we got, so let's call this difference here. So we have to check if it's smaller than I, because this here is the k we are looking for, and we need k to be here, I to be here, and j to be here, right? So we need it to be smaller than I. And so what this would mean is that instead of doing this for loop, if we have a map here that is just x to I for I and x in enumerate of the original array, then here, instead of these two for loops, we can just say, well, the difference is just aj minus ai, right? That's supposed to be the value of k, right, at the index k. And so we could just check if that difference is in the index map. That means there is a value. And so here we need to also confirm that the index map for diff, which is the k value here, is smaller than I. So this is k, right? And now we could just say, okay, so k is equal to index map of. So instead of looking for k with the for loop, we can just look for it with the map check here of diff. And now we can use the same recurrence. And that will optimize our loop here. It will increase space with O of n because we will be using this additional map. But now, instead of O of n, we will be using just O of n squared space, right? So it's definitely an improvement, right? Okay, so now let's write this improved, optimized version of the DP and make sure it works on some examples. Okay, so now let's write down quickly the DP solution that we saw in the overview. So first we need, again, the length of the array. Then after that, we need to go with, so we need to do initialize our DP array. So 2 for in range of n here. And then range of n here as well. And now we need to do our for loops here. So range of n for j, I is before j, so we have I here and zj. And now we are not going to look for k. We are going to instead have the map here that will allow us to easily find it. So we are going to map value to index, and we are going to just get the index and value by enumerating on the array. And now here we can check if there is a value for k, and so that's just the difference between aj and ai. So let's call this maybe k val, and check if that exists, right? So if k val is in the map and the index here, which is index map of k val, is smaller than I because we want k to be before I, only in that case that means we are in the condition where we can use the recurrence. And so recurrence is just dp of ji is equal to the max of dp of ij again, sorry, ij I meant, and then we increase by 1 if we found k, so k is going to be the dp of k and I. And k here is just the index of the value that we found. And then we can get the max. And so to get the max, we just get let's call it res, is equal to the max for each values for values in DP. So the max for all the DP values, basically. And then we can return that value if it's bigger than 2. Otherwise, we should just return 0, because that means we don't have a subsequence here. Now, let's just rename this and test. Cool. So those test cases pass. And this here is O(n) squared time, because we are doing these 2 for loops. And then we have O(n) space, O(n) by n space for the DP array, and then O(n) space here for the index map. But we improved the time complexity from O(n) cubed to O(n) squared. Yeah, so that's it for this problem. It's a good application of how to apply dynamic programming, and also the initial brute force solution is pretty clever, using a set and kind of reversing the way we think about the problem. Instead of thinking about, can we check if there is a Fibonacci sequence, considering just the Fibonacci sequence itself and checking and stopping when we reach an element that is not in the array, but that should be if the subsequence was a Fibonacci subsequence. So this is a clever application, a clever way of solving it using brute force, and then a dynamic programming solution optimized here. Yeah, so that's it for this problem. Thanks for watching, and